Okay, so today we're going to be practicing implicit derivatives. Okay, so basically implicit differentiation is when you're taking the derivative and the variables don't match. Okay, and it's a form of chain rule. Okay, but um, very simply, we can use our other rules to help us out as well. For instance, in our first problem, we're taking the derivative with respect to x of ln y. Okay, now I have the chain rule right here to kind of remind you how the chain rule works. Okay, so if we follow chain rule says that we do the inside and the outside. Now I like doing natural log using its chain rule variant, this one. So d over dx of ln of u equals du over u. Knowing this formula helps me out tremendously. Or some people write it like as 1 over u times du, either way. Okay, so since my variable is y and I'm taking the derivative with respect to x, I get the derivative 1 over u, which in this case u is y, so I get 1 over y, times the derivative of u, and since u is y, the derivative of y is dy over dx. So this is my derivative. Okay, now because it's implicit, that's why we end up with this dy over dx. We're taking the derivative of y with respect to x. Okay, the second one. Again, we could use like the inside-outside rule on this one. Or we could use the formula rule. Formula rule says d over dx of cosine of u equals negative sine u times the derivative of u. Okay? Now if we use inside-outside rule, we got to take the derivative of the inside, which is the y squared. So the derivative of y squared is 2y dy over dx times the derivative of cosine, which is negative sine y squared. And that's your derivative. Now the only difference if we did the formula that's sitting above it is that this part right here, which is du, is this part right here. This is my du, and this is my sine u. Okay? All right, let's look at our next example. We're taking the derivative of 2xy with respect to x. Now, there's two ways of doing this. So the first method or thought is grouping the 2x together, and that's what I would do. But we're going to do product rule. So there's one way of doing it where you group 2x together times y, and then there's another one where the constant is 2 and then you just take the derivative of xy. So I'll do it both ways so you can see it. Okay, so the first way in blue is going to be with it as 2x. So when I take the derivative, product rule, the derivative of 2x is 2 times the second y plus 2x times the derivative of y, and the derivative of y is dy over dx. So that is what you would get if you grouped it, the 2 and the x together. Now, if you grouped it this way, you would get 2, and then inside you get the derivative of x, which is 1 times y, plus x times the derivative of y, which is dy over dx. So either way, you get the same thing. This way, if you group the x and just x and y, you've got to distribute the 2 in to get to where you are on the top. But that's the derivative. Okay? E to the y. Now again, this would be one of those times where using the formula for chain rule. E to the u, the derivative of e to the u is e to the u times du. So in this case, the derivative of e to the y is e to the y times the derivative of the inside, which is dy over dx. Okay? So they're pretty easy by themselves. Okay, so if you're just taking the derivative of one expression or a piece of an expression, pretty simple. Okay, now let's look at when we have to take the derivative of, say, an equation. Like find the derivative of x y squared plus y equals x squared plus 3. So In this one, we're following those 4 steps in my other video in the notes, where it says first you take the derivative of both sides with respect to x. So we're going to take the derivative of everything with respect to x. Okay? Then you move everything that has a dy over dx to the left, everything else to the right. Factor out the dy over dx to get it by itself, divide, and that's your derivative. Because when we talk about finding derivatives, it should be dy over dx equals something. Okay? So again, this first part, I've got a product rule. I've got x times y squared, taking the derivative. So I got to do product rule. So that part I'm going to do right here in purple. So this is the derivative of this purple part. So the derivative of x is 1 times y squared plus x times the derivative of y squared, which is 2y dy over dx. Okay? Plus, then it's the derivative of y. That's this blue part. The derivative of y is dy over dx equals, now the derivative of x plus 3, which is 2x. Okay? So there's the derivative. But we're not done, because we got to get dy over dx by itself. Okay? So let's rewrite this so that it's easier to read. So I got y squared plus 2xy dy over dx plus dy over dx equals 2x. Okay? So now notice that I have 2 things with dy over dx. I have 2xy dy over dx and plus dy over dx. So like I said, what we're going to do is we're going to keep anything that has dy over dx on this left side. Everything else will move to the right side. So subtract y squared from both sides. Okay? And since both these terms, specifically this term here and this term here, both have a dy over dx in it, I'm going to factor that out. So I take out my dy over dx. What am I left with here in this first one? 2xy. Plus, what am I left in the second one? 1. And that's going to be equal to 2x minus y squared. And then, like we said, we want to get dy over dx by itself, so I'm going to divide both sides by 2xy plus 1, and this whole side by 2xy plus 1, which leaves me on one side with dy over dx being equal to 2x minus y squared over 2xy plus 1. And that is our derivative. Okay? All right. Now, our last part. It says take the derivative with respect to t. And we've got v equals 4/3 pi r cubed. Now, this is the volume of a sphere. Okay? So we're going to take the derivative with respect to t. Now, I got to take the derivative of all of my variables with respect to t. Now, when I do that, I'm going to get dv over dt, because the variables don't match, equals 4/3 pi times the derivative of r cubed, which is going to be 3r squared, times dr over dt. And we simplify this a little bit, so we get dv over dt equals 3 times 1/3. So this is 4 pi r squared dr over dt. And that's the basics for implicit differentiation.